Hi, welcome to my channel. Today, let's try to solve longest palindromic substring. What is palindrome? Palindrome is a word that spells similar from the back side as well as from the front side. If you see BAB, it spells same BAB from the front side and from the back side BAB. This is a palindrome. So here we need to find the longest palindromic substring from a given string. Okay? Substring is continuous. So when you read the question, what is the first solution that comes to our mind? The solution is, let's try to generate all the possible substrings for the string, and for each substring that is generated, let's try to check if it's a palindrome or not. If it's a palindrome, save the length, save the substring, and compare it with existing maximum length, and then return. So that's one of the solution. What is the time and space complexity for this? We are generating each possible substring, which is n square, and for each possible generated substring, we are checking if it's a palindrome or not, which is linear time again. So the total time complexity of this problem is, of this algorithm, is O of n cube. Okay, and space complexity, we are not using any space, so space complexity is constant. So can we optimize this solution? Yeah, let's try to look at the problem in a different way. When does a substring, a palindrome, it is a palindrome, when does, let's consider it as start and it as end. When is this substring palindrome? It is palindrome when the character at the start index is same as character of the end index, and the substring of the index starting from start plus 1th index to end minus 1th index. If this is also a palindrome and this character, start character and end character, are palindrome, then only the substring from start index to end index is palindrome. So if you see this formula, palindrome start to end equals character at start is equal to character at end, and the palindrome starting from start plus 1th index, this substring, basically this substring should be palindrome, right? If you consider this formula, this is the important formula. There is one catch here. What's the catch? How will you decide what is the start and what is end? Okay, you know, right? You are checking the palindrome for the start to end index. How do you know for which substring, for which start and which end you have to do? Will you do that for all the possible start and end? That's not required. So let's see for each specific length, length A, length 2, length 1, length 2, length 3, length 4, okay, length 5. For each length, how we can calculate it? So this is the recursive function. We can pictorial this recursive function in an 2D matrix. Okay, let's try to fill this matrix by using this recursive function and for each specific length. Okay, length 1 starting from B and from B, all the length 1 are palindrome. All single characters are definitely a palindrome. Palindrome, 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 palindrome. All these are palindromes. Okay, now I'm considering length 2, guys. Length 2, is B equal to A? No, so it is not a palindrome. We don't need to consider the opposite way. So here it's nothing, so we are just marking it as not a palindrome, they're not equal. So if you see B is equal to B, A is equal to B, no, it's not a palindrome. B is equal to A, no, it's not a palindrome. A is equal to D, no, it's not a palindrome. So length 2, we did not find any palindrome. Let's see for length 3, guys. Okay, B is equal to B. Yes, one of our condition is satisfied. Now what is the other condition? My start plus 1 and end minus 1. End minus 1. So this place. Is this a palindrome? Yes. These two are equal and this is palindrome. So yeah, this is palindrome. So what is the string here that you're saying? B, A, B is a palindrome. Meanwhile, you can just save. It's a palindrome. Max. What is maximum length? Maximum length 3. We saved it, and we can save the string as well. Okay, similar way. Now we see here A starting from A, ending from A. This they both are same. First condition satisfied. Now I'm checking for second condition. Second condition is this place start plus 1. This is part is start, and this part is end. They both are same. So yeah, this is also satisfied. This both are same. This is also palindrome. So what is the string? A B A is a string. Now if you see B is equal to D, no, so this is not a palindrome. Similar way, B is equal to A, no, it's not a palindrome. A is equal to D, no, it's not a palindrome. B equal to D, similar way like this. What's happening? You filled this matrix, two-dimensional matrix, in this format. Now, what is the time and space complexity for this algorithm? We are populating this string, means 2D matrix for each particular length. For each particular length, what you are doing? For each particular length, we are filling up this matrix table, right? By checking for that particular length and for each substring possible for the of that particular length. So what is time complexity? Time complexity would be O of n square. What is space complexity? Space complexity would be, we are using 2D matrix, right, to store our data. We are using 2D matrix to store our data. We are 2D matrix to store our data, which is O of n square again. Okay, time and space complexity for this algorithm is O of n square. Can we further optimize it in with respect to space, because we are using some extra space, right? Unnecessary extra space we are using. Let's think about it. How it is if we consider each character as a middle point and expand towards right and expand towards left. Okay, think like this. I'm considering this B as a middle point now, and I expand towards right, left. Okay, I expand until when? Until that's not a palindrome, right? The advantage of finding the middle point, or advantage of considering a character as a middle point, is you can stop it whenever it breaks the palindromic formula, right? You see here, right, what we are doing in this formula also, what we are doing for a substring to a palindrome from start to end, we are checking if the substring two size lesser than that is a palindrome, right? For this to be palindrome, we are checking if this is palindrome, right? That's here in this problem. What we are doing, we are coming from outer to inner, but now what we'll do, we will go from middle to outside. We expand from the middle, so that whenever we find dissatisfying condition, we'll just stop there. We don't need to expand. Okay. What we can do, we consider this this as a middle point. We go towards left, we go towards right. Here there might be two possible cases where the length of the length of the palindromic substring can be odd or even. Okay, it can be an odd, yeah, it can be odd length or even length. Odd length can be means only one guy, it starts with only one person as the palindrome. Even number can be two elements as a palindrome. Okay, what can be the time and space complexity of this algorithm? I'm checking for first guy, I'm expanding towards outer side. So for each character we are doing it. For each character I'm expanding towards both the sides. I'm expanding towards both the sides. I don't want to expand towards one side. I'm expanding towards both the sides. Okay, let's consider this example. This I'm expanding this side, I'm expanding this side, they both are same. Again I'm expanding towards this side and this side. For each character we are doing that. That's why for each character we are expanding all the time. So the time complexity would be O of n square for this optimized solution. What should be the space complexity? Are we using any extra space here? No, we are not using any extra space. So the space complexity would be of constant. Yeah, so I have implemented this solution. Let's try to look into the code. Okay, what we are doing here. So that for each, I'm considering each character as a middle point. And if you see, first one is I'm considering that as an odd number. So for odd number, what I'm doing, odd number is length starting with 1. So let's consider this as a black box for now, where this will give me what is the maximum stretch that it went to. What is the maximum stretch that it went through from the left side and towards the right side? What is the maximum stretch? This is only one character, right? So I'm just giving this as starting point. And even length. What can be the even length? It can be my point and plus 1 point. My point is the starting point. I mean the whatever character is there, that point and the starting point. It's I plus 1. Okay. Now you got both of them. You consider that character as an even length even length middle palindromic character and odd palindromic character. Okay, now you calculate the maximum. We found the maximum, and here what you are doing, we are trying to calculate. We know the middle at this point. What is my middle character? Now from here I am trying to calculate my starting point and end point. That's it. I'm calculating the starting point here, I'm calculating the end point here. Now let's look at what is this function doing. If you see here, I'm expanding towards right and towards right at the same time, right? Here this is just a validation to check we don't go out of bound. I'm expanding towards left, I'm expanding towards right, and when both are equal, I'm expanding. Whenever they are not equal or they are out of bound, I'm just returning. Okay, this is how we are doing it. So we looked at 3 approaches. One is finding all the possible solutions, all the possible substrings, and returning the result, which is O of n cube, and space complexity does not have any space complexity, it's a constant time. The second approach is we found a formula where we made use of a formula which stores and we may use of a two-dimensional matrix which stores the previous lengths if it's a palindromic or not. We made use of that information which from which our time complexity reduced from O of n cube to O of n square, but our space complexity increased from constant to O of n square because we are saving the previous length palindromic information. That's one of the solution. And the third solution is considering my character, the present character, as the middle point and expanding towards left and towards right. This is the optimized solution that we found, and we have seen the code as well for this solution. And time and space complexity of this solution is O of n square, and for time complexity, for space you are not using any extra space, thus you are not having any space complexity. Thank you.